And method number 2 is, again, as we had with the dot product, is a geometrical method. Let me try to work on this board in between. If you know vector A, and you know vector B, and you know that the angle is theta, then the cross product C equals A cross B is the magnitude of A times the magnitude of B times the sine of theta. Not the cosine of theta as we had before with the dot product. It is the sine of theta. So you can already immediately see that this will be 0 if theta is either 0 degrees or 180 degrees, whereas the dot product was 0 when the angle between them was 90 degrees. This number can be larger than 0. If the sine theta is larger than 0, it can also be smaller than 0. Now we only have the magnitude of the vector, and now comes the hardest part. What is the direction of the vector? And that is something that you have to engrave in your mind and not forget. The direction is found as follows. You take A, because it's first mentioned, and you rotate A over the shortest possible angle to B. If you had in your hand a corkscrew, and I will show that in a minute, then you turn the corkscrew as seen from your seats clockwise, and the corkscrew would go into the blackboard. And if the corkscrew goes into the blackboard, you will see the tail of the vector, and you will see a cross, little plus sign, and therefore we put that like so. A cross product is always perpendicular to both A and B. But it leaves you with two choices. It can either come out of the blackboard or it can go in the blackboard. And I just told you which convention to use.